and welcome to the 24 Hours of Past, Growing Our Community. We're excited you could join us today for David Maxwell's session, Turbocharged Transaction Logs. This 24 Hours of Past event consists of 24 consecutive live webcasts delivered by up-and-coming speakers and experts from the past community. All sessions will be available next week on the 24hoursofpast.com site. My name is Scott Murray, and I'm one of the co-leaders of the Business Intelligence Virtual Chapter. I have a few quick introduction slides before I hand over the reins to David. He will speak for probably about 40 to 45 minutes, and then we'll move on to the Q&A where you can ask questions that you may have. If you're having issues, just go ahead and type your questions into the question pane on the GoToWebinar control panel, and someone will be there to assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off some of the questions to the speaker. Since all attendees are muted, you'll need to submit your questions by typing them in the Q&A field. And also note there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It'll show up on your screen at the end of the presentation. I'd like to take a moment, of course, to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. In addition, I'd also like to thank our support sponsors for this event, SQL Sentry, HP, and SolarWinds. The staging of this 24 Hours of Past would not be possible without their support and dedication, and they're the reason for this event is available free of charge. Next, I'd like to bring your attention to the upcoming PAST Summit, taking place in Seattle, Washington from October 27th to the 30th. PAST Summit will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PAST Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 attendees from all over the world, PAST Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. Most importantly, PAST Summit delivers on providing you with the answers to your SQL Server issues, along with knowledge, strategies, and skills you need to stay ahead of your curve. Go ahead and contact your local chapter or your virtual chapter for a discount code to save $150 off. Optimize your savings by registering before the end of Sunday, July 12th. To find out more about the PAST Summit, of course, visit www.pastsummit.com. And now, please let me present the speaker of the hour, David Maxwell. We're excited to have David presenting to us today, and I'm going to go ahead and turn over the reins to him. And just remember, if you have any questions, go ahead and post them in the Q&A section.
All right, Scott, thank you for the intro. We greatly appreciate it. And this is Turbocharged Transaction Logs. My name is David Maxwell. I'm glad you decided to attend my session today. So a brief overview of what we're going to cover in today's session. First, we're going to talk about what's really in the transaction log. It's easy enough to say that the transaction log is just a record of all transactions against the database, but there's a little bit more to it than that, of course. So we're going to delve into the internals of that just a little bit. We're going to talk about how the log manages all of that data that gets thrown into it. There's a lot of information that gets thrown. In fact, there's actually more information that gets written to the log than gets written to the database on a change in most cases. And we're going to talk about how SQL Server actually controls that space and uses it. We're going to look at some common potential problems that you may have with the transaction log and some potential solutions for those. And then finally, we're going to take a little bit of time to talk about ways that we can get a little bit more performance out of the transaction log. So what's really in that transaction log? Well, SQL Server makes a lot of changes to a database, even when they're not user-initiated changes. It could be changes being made at the system level. But for purposes of illustration, we're going to go ahead and we're going to consider a single row insert to a data page within the database. Now, SQL Server stores this data in 8K pages. And when it's going to make a change to one of those 8K pages, it reads it off of disk and puts it into SQL Server's buffer pool of memory. Now, before I can change that page, a record of that change is written to the transaction log first. SQL Server does this to enforce durability for the ACID properties of database transactions. So transactions must either complete or roll back. That's the A, the atomic property, and D, durability. Even if SQL Server crashes, it has to be able to replay finished transactions. So That's why they're written to the transaction log first. Now, when that record is written to the transaction log, a little bit of extra space is reserved in the transaction log in case you need to roll that transaction back. I'll show you what that looks like as soon as we get to the demo. So once that's been completed, the page in memory can now be modified and that new row can be inserted into the database. Now, one of two things can happen at this point. If the transaction is committed, then we get a commit record written into the transaction log. So far, for a single row insert, we've actually written 3 rows into the transaction log: the begin transaction, the insert, and now a commit record. So this is what I meant when I said that actually more information can go into the transaction log than is going into the database on any given transaction. Now, the other thing that can happen is if the transaction gets killed or rolls back for another reason, then we get what's called a compensation record written into the log. This is a record that says, okay, we're changing this page back to the original values. And then once that's done, the page in memory gets changed back to its original values, and we move on from there. Now, before I go on, I want to say a brief word about Checkpoint. People have obviously heard of Checkpoint, and people who I've talked with about Checkpoint, I want to clear up one little misunderstanding that's very common to it. Checkpoint has one job and one job only. It writes changed pages, or dirty pages as they're sometimes called, in that buffer pool memory back to disk. That's all it does. It does not control anything else to do with the transaction log. Now, this happens independently of the state of the transaction. So whether the transaction has been committed or rolled back, if checkpoint occurs and there's a page in memory that's been changed that hasn't been written back to disk, it will get written back to disk, even if that transaction is later rolled back. Now, by default, it only happens about once every 60 seconds or whenever you start a backup. Now, you can change the checkpoint interval. You would do that if you have a situation where you're getting lots and lots of very, very rapid transactions, and maybe you have a recovery objective that's a very, very short window of time. You may want to be flushing those pages back to disk a little bit quicker than you normally would. So there's 2 settings for that, and the first one is a server level setting called recovery interval. That's measured in minutes. The second setting for that is target recovery time, and this is measured in seconds. And I point that out because if you set those 2 things to the same number, you're going to get very, very different behaviors between your databases. Now, normally, about once a minute is pretty good for most SQL servers and for most databases. So normally this isn't something that you would change for any reason. But if you do run into one of those situations where you're having that really short recovery time that you need, this might be one good way for you to handle that. So let's go ahead and go to the first demo, and we're going to take a look at what's in that transaction log. Now, I've run some of this ahead of time just for time's sake, because we do have a limited amount of time today. But what I've done so far is I've went ahead and created a test database, and I've put a little function in it called getIntegerString from hex, and I'll explain why I did that in just a second. I've also started by setting the recovery mode to full. I'm going to talk about that in the next section, and taking a full and transaction log backup. So I'm going to use this function called fndblog to read in the transaction log. And fndblog takes 2 parameters, and it's the start and end log sequence number. Your log sequence number is basically your ID column, for lack of a better explanation, for your transaction logs. It details the sequence of the transactions as they are recorded in the log. And like I said, the log records a whole lot of information. And when I say a whole lot of information, I mean a whole lot of information. I could keep scrolling here all the way over to the right. There's actually 129 different columns returned by fndblog. So what I'm going to do is I'm just going to grab a subset of those columns and talk about a few specific ones that I think are important. Now, here's where I'm using this function, getIntegerString from hex, because remember I said that fndblog takes 2 parameters, the start and the ending LSN that you want to display from the transaction log. Well, when you run fndblog, it gives you those LSNs in hexadecimal, a 3-part hexadecimal number. But when you use them as parameters for fndblog, they have to be in decimal. Why it's that way, I don't know. If somebody does, please contact me and let me know why, because I think it's a little confusing. But so I'm going to go ahead and grab that LSN for later. So a few of the more important columns that fndblog returns, again, of course, there's the LSN, our log sequence number. There's operation and context. Operation, this is what I did. Context, this is where I did it. Log record length, this tells you exactly how much information is stored within the transaction log for that particular record. And then log reserve, this is what I was talking about earlier when I said SQL Server sets aside a little bit of space in case it needs to roll a transaction back. So you can see for this particular modification, we modified a row on the boot page of the database. It actually took us about 100 bytes worth of information to do that, but we set aside 196 bytes in the transaction log in case we need to roll that back. And if you're modifying a specific data page, like we talked about with our insert, this tells you exactly which page within the database was modified, file 1, page number 9. If you're modifying a specific record or a slot in that database, or in that object, it will tell you exactly where that is as well. I'm going to come back to transaction SID in just a second. If you take any locks, it shows you the lock information, and then out here we've got a description of exactly what happened. Now here's where I took my backups for this particular database, and we have the transaction records in there. Now, transaction SID is kind of cool because if you ever wondered, okay, who removed that row, or who dropped that table, or who did this or that to the database, if it was a named user, you can grab that transaction SID from the log file, from FNDB log, paste that into a query where you select against suser sname, give it that transaction SID, and it'll tell you exactly who did it. So there's my user ID right there. I'm going to go back and grab this last LSN number here. So now I'm going to go ahead and create a table called cookies, because I love cookies. And I am going to paste that last LSN in there so I don't have to reread all of those records that I had before. So if I go to the transaction log and say, show me what you had to do when you created that table, these are all of the actions that happened when that create table statement was issued. You notice I have a transaction name column now, and that shows where the create table was called. And a lot of things happened. Now, what I do want to point out here is I've added another column called allocation unit name. So this tells me every object that was modified that required a record in the transaction log. Now, you'll notice at no time does the name of my new table show up. That's because that table wasn't created yet. All of the metadata for that table was added to these system tables, but it wasn't actually created. I'm going to grab that last LSN again. So now I'm going to go ahead and insert a few values into that table. And of course, peanut butter cookies gets the highest ranking because they're the best cookie in the world. And paste that LSN here. So now let's see what the transaction log shows. Okay, now you see the name of the table showing up because now that table actually exists and I can insert information into it. I'm going to go ahead and scroll all the way down here, and here's where my rows were actually inserted. It shows the insert rows on a clustered index, and that clustered index is my primary key for the cookies table. And this even shows the pages and the slot numbers. Slot 1, or slot 0, 1, 2, 3, so those are the first 4 rows that I inserted onto that page. Another thing I want to point out is if I scroll all the way over here, I've added a few other columns to this query now, and these are called the row log contents columns. Now this is the content that was actually added to the database. It's showing up here in binary format, but this is the actual data that was put into that table. Okay, so now I'm going to take a quick log back up. So now I'm going to begin a transaction. I'm going to do it as a named transaction. I'm going to call it cookie roll. And we're going to roll the value for my peanut butter cookies, maybe I got a bad batch, back to 75. And then I'm going to roll back that transaction. So now let's see what that looks like. I'm actually going to make this null so that we can see everything that's in there. Okay. So a lot of things happen there, but what I want to show you is right down here. So here's the begin transaction. And like I said, I gave that transaction a name. So here's my name transaction, cookie roll, in the transaction name column. And started with this record right here, which was a modify on a clustered index. And if I scroll out here, so here are my row log contents column. So here was the initial value, which I said was 100, and it's being represented here as a binary 64. And I changed it to 75, which is 4B. However, I did roll that transaction back. So like I said earlier, next thing SQL Server had to do is it had to create that compensation record. And you see under the description column, it shows you right here that it's a compensation record. Now, compensation records are forward only. They can't be rolled back. So it does not store a before value for that record. It just leaves it blank and then stores the after value because we're changing this back to the value that it was before. And then finally, since that transaction was rolled back, we get an abort transaction. Okay. So, like I've shown you, there's a whole lot of information that's getting dumped into that transaction log on a regular basis. So how does SQL Server keep track of and manage all of that data? Well, it does it by taking that log file and breaking it up into smaller virtual log files, or what I'll refer to from here on out as VLFs. Now, the number of VLFs that you're going to get is going to depend highly on the size that the log is either created or the size that it grows at. So there's a formula for this. If your create size is less than 64 megs, you're going to get 4 VLFs. That also applies to the growth size, like I said. Anywhere between 64 megs and 1 gig, you're going to get 8 VLFs at 1/8 of the size of the create or grow. And then anything greater than 1 gig, you're going to start with 16 VLFs at 1/16 of the size. So under SQL Server 2014, things changed just a little bit, and this will be a benefit that I'll show you a little bit later. Any growth that happens on an existing transaction log that's less than 1/8 of the current size of that log is only going to create 1 VLF. So by way of illustration, let's say we have a 1 gig log file, and it's going to grow by 100 meg, which is the default 10% growth that you would get with SQL Server. And I hope everybody knows in here that the default 10% growth is really not a good idea. It can cause things to get out of control pretty quickly. But let's say we've got that default 10% set. We've got our 1 gig log file and 100 meg growth. For 2012 and lower, you're only going to get 8 well, I shouldn't say only, you're going to get 8 VLFs at about 12.5 megs each. But if you're running 2014, since 100 meg is less than 1/8 of the size, you're only going to get 1 VLF, and that'll be it. So, VLFs can be reused. The log is circular in fashion. If you get to the end of the log and there's space at the beginning of the log you can use, it'll wrap around and start writing at the beginning of the log. How does it do that? Depends on the recovery model of the database how these VLFs can be reused. So first of all, you always have to have at least one active VLF in the database log file somewhere. It's usually going to be the last VLF that was written to. Now, the VLF becomes active or marked as active when an open transaction writes a log record to it. That VLF is going to stay active until one of a couple things happen. Now, first of all the transactions within that VLF have to either commit or roll back. You can't have an open transaction in a VLF and reuse it. You won't be able to do that. So all the transactions have to commit or roll back, and this is where recovery mode starts to matter. If you're in the simple recovery mode, a checkpoint has to have occurred. Once that happens, SQL Server says, okay, all of those changed pages have been flushed back to disk. I don't need to hang on to those transaction log records anymore, and it marks those VLFs as available for reuse. It's also called truncating the transaction log, by the way, which is not really a term that I care for. I actually like marked available for reuse or made inactive. I think that's a more accurate description. Now, in the full or bulk logged recovery model, you have to take a log backup in order for those VLFs to be marked as available for reuse. You have to have a way to hold on to that transaction data in case you need it for rollback. Again, like I mentioned, the transaction log is circular. So if you reach the end of your transaction log, which means you've written all of those VLFs, the last VLF is active, but there's a VLF at the beginning of the transaction log that's not active, you will wrap around and start writing again at the beginning of that transaction log. Now, of course, if you've got no VLFs available for use, everything is in use, everything has active transactions in it, or you haven't taken the log back up yet and you need to write something and you need to start a new transaction, that log file is going to grow. So let's take a second and see what that looks like. So the first thing I'm going to do is recreate my test database. Should only take a second. There we go. And I'm going to take my full and transaction log backup. So now that I've taken that transaction log backup, everything should be available. Let's see if I'm... my apologies, I'm on the wrong demo file. But that should still work. Yes, it should. Okay. Okay, so here, using a function called DBCC Info, or sorry, DBCC Log Info, you can see these VLFs. This is exactly what it does. This is listing out all of these VLFs in the transaction log. Important ID is here. Here is your file ID. So transaction log by default is always going to be file 2. If you've added additional transaction logs, which we'll talk about a little bit later, you might have other file IDs showing up in here, but if you've just created a database, you're going to see file ID 2. File size tells you how big those VLFs are within your transaction log. Your start offset right here, this tells you where within the transaction log they start. And then these are two important columns right here. Status is what I was referring to as active or inactive. And you notice the first one is already set to a 2. That means that that VLF is active. And it's going to stay active until all of the transactions in it have been committed and it's been backed up because we're in a full recovery mode. Also important is the sequence number. This tells you in which sequence all of these VLFs were written to. Let me show you how that works. I'm going to create my vacation spots table because I like to travel and it's fun. And insert some places that I haven't been to, that I have been to or would like to go to. And I'm going to use DBCC Log Info again and see what the status of my VLFs is. Okay, so the amount of information that I've inserted so far wasn't very much. And you know, this log file is about 1.2 megs. It's a decent size, so it didn't require me to spill over into the next log file. All of the transaction data that I've written so far fits nicely within that first VLF, so I didn't need the second one. Now I'm going to create another table for my travel diary, and I'm going to insert about 400 records into it. So this is going to be a significant amount of data, much more than I had in the first transaction. So now if I check log info, right, so now it's showing me that we've got enough information in there to fill up at least 2 more of those VLFs. And you see the sequence number has been incremented for those as well. We started with 184, 185, 186. So we're doing pretty good. So now I'll take another transaction log backup. And if we've done our math correctly, so we've had our checkpoint. Those transactions were committed. And this was the last VLF that we wrote to. So this is exactly what we should expect to see. These first 2 VLFs are inactive. This VLF is active because there always has to be one active VLF.
Hey, David, this is Scott. I had a question that popped up that I think was somewhat relevant, if you would mind entertaining it real quick.
Sure, what's that?
Brett asked, what was the logic that changed for 2014 in the number of VLFs?
What was the logic that changed? That is an excellent question. One of the demos that I'm going to show later is going to show you why it's a much better idea to have less VLFs in the transaction log. As far as specifically what logic changed, that's a great developer question as far as the SQL Server development goes. I wouldn't be able to tell you specifically. I do know that the algorithm has changed, and that's what it changed to, but I'm not entirely sure how they came to that particular conclusion.
Okay, we'll just look for that demo coming up. So sounds good. Thanks.
Sure, no problem. Okay, so let's do a little bit more work in this database. Let's add about 300 more records, and that should take us close to filling up our transaction log VLFs. Okay, so we've got, so our sequence numbers, okay, here you can see we've gone 186, 187, and then we've wrapped around to the beginning of the transaction log again, and now that is sequence number 188. So let's do a little bit more work, add about another 300 records, and we should be able to force a growth. There we go. So additional information that we get this time, you can see this will tell you the LSN record within the transaction log that said, hey, I need to create some more VLFs. I'm going to do that now. And notice it's created 4 of them for us because our growth was less than 64 megs. And our sequence numbers have actually skipped over. These sequence numbers don't have to be in order as far as the transaction log is concerned, and that's specifically because it is circular. So here was 188, our second VLF was available, it became 189, and then we skipped over these two because they were already active, and we wrote to the first inactive one, which was VLF number 5 here, and that became number 190. One of the cool things about having so much information in the transaction log is that it actually becomes very, very easy to filter on. You'll notice that I've added a column to this query right here called VLFs added. If I select against FNDB log where VLFs added is not null, if I can use my mouse properly today, here we go. If I select against it where VLFs is not null, this will show me the exact transaction log record where those VLFs were added. And in addition to, here's my operation in context, modified the file header. Tells me exactly where it was, so file ID 2, again, your transaction log file, and the 0 would be your header. Says exactly what it did. I grew the transaction log from here to here, and the VLFs added column actually gives us every information for every VLF that was added to the log. It gives us its size and its offset. So if we take another transaction log back up to clear that out, we go back and look at our VLFs again. So all of our committed transactions that had been checkpointed, flushed to disk already, are gone. And now the last VLF that we wrote to is our only active VLF. Okay. So let's talk a little bit about troubleshooting the log and how we go about doing that. Common scenario that probably most of us, if not all of us, have seen is the log runs out of space. Log runs out of space, database stops, nobody can process any inserts, updates, deletes, people are complaining, and calls are coming in hard and fast. 99 times out of 100, causes for this is one of two things. One, we have a long-running transaction that's holding on to one of those VLFs and won't let go, and everything's trying to work around it. Other thing is, most likely, we've got log backups that aren't keeping up, or in a lot of cases, aren't being done at all. I know a lot of us have probably also seen that database that's maybe 500 megs, maybe 1 gig in size, but it's got a 30 gig transaction log because somebody set it to full recovery mode but never started log backups. We've all seen that. So how do we handle those particular situations? Well, we got to start taking log backups, or we have to increase log backup frequency. Log backup frequency isn't necessarily just to control recoverability. It can be used to control the size of the transaction log too. Now, of course, you're creating more log backups, but it is a really good way to control the size of the log, especially if you take very, very frequent backups. It does give you slightly better recoverability too, but it's not just about that. Sometimes you got to be a little violent. You got to kill an open transaction. If you have a transaction specifically that's holding on to a lot of space in the log, you might have to kill it and let it roll back in order to be able to reclaim that space and use it for other transactions. Another thing that you can do is you can add another log file in a different location. This one can get a bit dicey, but it is one way to solve the problem. You can add as many log files as you need to, as long as they're in different locations and you have the space available to be able to do that, and SQL Server will just sequentially go through that log file and continue writing to it and creating VLFs in it if needed. So, a few caveats to handling things. First of all, that rollback that I mentioned, it will take time, especially if it was a really, really complicated transaction. It's probably going to take just about as much time as it did to get to where you are right now. So if the transaction's been running for about 3 hours, it could very easily take about 3 hours to roll back. So you do want to watch out for that. Try to determine what your transactions are actually doing before wiping those out. And I do have a query that I'm going to show you in a demo coming up that'll let you see who's using what resources within the transaction log. And then if you do add additional log files, remember to remove those when you've finished troubleshooting the problem, when you're back to where you need to be. There's actually no advantage whatsoever to having additional log files on your database. It's much better to have just one single log file. It's better for recoverability, and there's no performance benefit. Log files are not written to in parallel. They're sequential. It's going to go one at a time, so there's, again, no benefit to multiple log files, except to be able to get out of this particular situation. Another common problem that we run into, VLF fragmentation, having lots and lots and lots of little VLFs cluttering up your log. We want to avoid this. So again, causes for this, improper growth settings. You've got your growth settings set too small. Solution for this, you want to determine your correct growth setting first, and you're going to do this by trying to determine how big your transaction log actually needs to be. Once you've done that, you go ahead and shrink the log file down, and then pre-size it to exactly what it should be. Maybe it should actually be 5, 6 gigs or even larger, depending on the workload of your database. And this is something that you would actually determine through testing. Now, caveats to that, watch out for what I call rubber band logs, and a rubber band log is one that gets shrunk and grows on a regular basis. Some of us have probably seen this. In fact, probably a lot of us have seen this. You go into a situation where someone hands you a server and you find a job on that server that shrinks the logs for all the databases every night. I have seen this before, and it horrifies me. It probably horrifies you too. And this is what I call a rubber band log. The reason for that is transactions are delayed while the log is growing. Logs cannot be instant initialized like data files can. So every time you have to grow a transaction log, database activity stops. SQL Server 0 initializes all the space on the disk that it's going to use for that log. So in my case, in the demos here where I'm initializing, maybe 4 megs, it's not a big deal. If I was initializing 30 gigs because I had an improper growth setting, that might be an even larger problem. So 2 demos that I want to show you at this point. The first one is identifying transactions that are using the transaction log and cleaning up VLF fragmentation and what that looks like. So let me recreate my demo database again. Okay. And I'm going to create a test table called movies. I do occasionally like to watch movies. And I'll put some ones in here. And then I'm going to start a named transaction called Bond, James Bond. And I'm going to insert a record into this database for Spectre, because I'm looking forward to seeing it. And I'm going to use this query right here. So in order to determine who's doing what within the transaction log, we've got a couple of dynamic management views that we can use to do that. And the first one is dmtran database transactions, and that gives us the transaction log usage information as related to a database. And then the second one is dmtran session transactions, and that takes a transaction log usage information and relates it back to a specific session. So when I run this, now remember, I've started my transaction, Mr. Bond here, and I've inserted a record, but I have not committed that transaction yet. So here's the information that I'm getting out of this query. I get the database name, the session ID, who's logged in as using that session, what time that transaction started, which can be very important. You want to know when that transaction actually started, and that might actually give you an idea of how long it's going to take to roll back, in addition to how many records I have for that transaction. Now remember, I've only inserted 1 record, but this is showing me 2 transactions. And again, the reason for that is that I have to have that begin transaction record written to the log first, then I can write my modification record, which is that insert. And then here under transaction bytes, it shows exactly how much space I'm using within the transaction log right now. And this can be very useful, especially if you're looking for someone who's using a really, really large amount of the transaction log. This is being able to filter on that is going to help you out right there. So now let's go ahead and have Mr. Bond committed. And we'll run that transaction query again, and let's see what we see. Okay, so that transaction has been committed. That's done. Now, the important part about this is this query works for transactions that are still in flight. So if you have transactions, lots of transactions that are committed and still taking up a lot of space within log, we don't really need to hunt those down. If we can take a log backup, that'll clear that space back out, and we'll be able to use those parts of the transaction log again. But if it's a transaction that's still in flight and holding on to large amounts of that transaction log, that's what this query is going to be able to tell you, and then you'll be able to take the appropriate action based on that. Okay, so let's look at VLF fragmentation now. And I'm going to, once again, you notice that I keep recreating this test database, and the reason that I've done it this way is because I wanted you to be able to run these scripts independent of each other. These scripts, by the way, they're not with the presentation materials on 24 Hours of Past site, but you will be able to download these from the resources page on my blog, which is dmmaxwell.wordpress.com, which was shown at the beginning, and you'll be able to get it if you get the recorded session as well. Okay, so I have created my database, and this time I've done it with a 16 meg transaction log. I'm going to hop over here and use DBC Log Info, and that's going to show me I've got my first active VLF, sequence number 185, and these are about 4 megs apiece, which is exactly what I would expect for a 16 meg transaction log. So now I'm going to run a loop that's going to grow this transaction log out 16 megs at a time. And this is going to take a few seconds to run. So I hope you'll bear with me while this finishes. Hopefully my hard drive is behaving today. Okay. So right around 10 seconds or so. And 2 functions that I want to show you at this point. First of all, DBC Log Info again. So this is going to show me all of those transaction log growths. All the way down, so I ended up with 512 VLFs. That's a lot. Probably something that I would want to avoid. And then down here, I'm running DBCC SQL Perf log space. And this just gives you, probably many of you already know this, but for those of you who don't, this just gives you a quick overview of for every database on your server, how big the log is and how much space is actually being used within that log. So we've got large amounts of VLFs in this log. We want to get rid of those. We want to get that down to a reasonable number. First thing we're going to do is run a shrink file, not a shrink database, but a shrink file on file number 2, which is our log file, and bring that back down to 16 megs. If I run my log info, okay, so here we are back down to 16 megs, 4 VLFs at 4 megs each. So now I'm going to do the same thing, except I'm going to modify that file and I'm going to grow the whole thing out to 2048 megs or 2 gigs all at once. And then we'll see what that looks like. This should be ever so slightly faster than running that loop, even though we're using pretty much the same amount of space. And there we go. So now we have our growth out, so we've got 20 VLFs and a little bit larger size, much more manageable. Okay, so talk a little bit about improving log performance and what that means. The transaction log is, I think, one of the critical parts of the database. It receives all of this information very, very quickly. For any change that happens to the database, you want it to be as fast as you can possibly get it. So what are some ways that we can do that? First of all, we want to look at improving our overall I/O. Anything you can do to make the disk subsystem or the storage system that you have that transaction log on faster, you definitely want to do that. This will be a good case for the use of flash storage, SSDs, If you can get it on a really, really fast place in the sand, you definitely want to do that. Anything you can do to get more storage performance, get your transaction logs on that location that has more storage performance, you definitely want to do that. So faster disk subsystems is one. File fragmentation, this is another good thing that you want to keep an eye on, especially for those rubber band logs, the ones that are growing, shrinking all the time. They can get fragmented on disk. SQL Server likes to write sequentially for transaction logs, not randomly. So anytime you can get that file to be contiguous on disk, that is a good thing as well. Now, the improvement for that can be limited. A lot of it depends on actually how much insert, update, delete, how much change traffic your database is actually getting. And another thing you want to do, isolate active log files to their own I/O path. Get them away from competing I/O loads, whether it's from data files or tempdb or anything like that. Now, there's a caveat to that. Having multiple log files on one volume, that's random I/O. And remember, SQL likes sequential I/O for log files. So if you've got a bunch of log files that aren't very active, not a whole lot of changes in the database, then yeah, sure, you could probably put those on a single volume. But if you've got one log file that's getting a lot of traffic, getting written to very frequently, you're probably going to want to put that on its own I/O subsystem if you can, get it, again, to get it away from those competing loads. Pre-allocate your log size as much as you can. If you can avoid a log growth, that's time that your database would have spent idle that it can keep on running. Again, monitor those VLF counts. You want to keep an eye on those and make sure that you don't have too many VLFs within your log file. Auto-grow, as far as log space goes, that's fine for a fail-safe, but again, anytime you can avoid an auto-grow, you're doing better. You shouldn't rely on it unless you absolutely have to. Again, keep it on as a fail-safe. Auto-grow is not a bad thing, but you want to try and proactively manage the space in your transaction logs. Do less work. Now, what in the world do I mean by that? Do less work means write less transactions. It doesn't mean insert less data. You can do multiple inserts within a single transaction. This is a bit of a balancing act, and a lot of it depends on the size of those inserts and the performance of your system in general. So sometimes it might be better for you to do lots and lots of really small transactions or to batch those into larger and larger transactions. You may hit a point of diminishing returns, but again, this is something that you're going to want to test. Sometimes this also has to do with the design of the system as well, and I'll show you exactly what I mean by that in just a second here. So I've got two demonstrations that I want to do for you. One is for VLF counts and how those affect recovery time, and then we're going to look at a little quirk with index fill factor and how that affects the transaction log. So we're going to start by having a race. Now I've actually run all of this already just for the sake of time, but what I've done is I've created two databases here. They both have 2 gig transaction logs, but for the first database, which I'm calling small VLF, the log was grown in 4 meg chunks. For the second database, large VLF, I did one single 2 gig log file. So if I use DBC Log Info, show what that looks like. So here's my first database, small VLFs. They're all 1 meg each, and I've got 2,048 of them. Now, that seems like an arbitrarily high number, but I have actually seen higher numbers on client systems and in production systems as well. And I'm sure probably some of you have as well. And then here's my second database with that one single 2 gig file. It was created with 16 VLFs at 1/16th the size. So now we're going to have a race. And what I've done is I've actually taken transaction log backups of both of these databases, so there are no transactions in these databases to recover. There's nothing to replay, nothing to roll back. All we're going to do is take those 2 databases offline, and then I'm going to bring them back online and see how long it takes to do each one. And this time I'm not going to talk over it. So for that 12 seconds of dead air that you just enjoyed, 11.5 of it was waiting for that database with all of those small VLFs to come online, and only 223 milliseconds was for the database with the large VLFs. Now, Imagine what that would have been like if we'd actually had transaction information in those databases and had to recover that as well. That could have taken an interminable amount of time. This is something that you're going to want to consider when you plan your recovery strategy. It does take time for those databases to come back online even after the restores have been completed. I'm going to drop those right now. Okay. So I mentioned index fill factor a little bit ago. This is what I was talking about. I'm going to go ahead and create my test database again. Set this up. And I'm going to create a table in here called fragment me. And you'll notice, what am I using for my fragmentation column? Unique identifier. Probably one of the worst choices for a primary key ever, but there are cases where it needs to be used. And I'm going to insert about 4,000 records. And then create a clustered index on that GUID column, and I'm going to do it with a fill factor of 100. And let's take a look at the fragmentation on that, which should be nothing exactly, because I just created that clustered index. So 0 fragmentation and about 99% page density. So all of those 8K pages are about 99% full, which is pretty good. We'll back up my transaction log to clear those records out, and I'm going to insert about 1,000 more records into that table. So that wasn't too bad. It happened pretty quick. So what does my fragmentation look like now? Yikes. 98% fragmented, and my page density dropped from almost 100%, which is pretty good, down to 60%. That's pretty scary for multiple reasons. What I want to show you here is, let's take a look at this log file real quick. So what I want to do is I want to see, after that transaction log backup that I took here, counting the inserts, how many total log entries did I have, and how many of those did I need for page splits? So 6,000 some total entries, and 147 of those were for page splits. Let's see if we can do better than that. So I'll go ahead and back up my transaction log again, truncate my table, and set that up again. So I'll put in my 4,000 initial values and rebuild that index, but you notice this time I'm going to do it with a fill factor of around 60. So I'm leaving 40% free space on each of those 8K pages. Now I'll back up the log again. And going to insert my 1,000 records again. Again, not too bad. So what does my fragmentation look like this time? Nice. Only 1% fragmentation, and my average page density actually went up from 60% to almost 75%. That's pretty good. Now, what about my log usage? Let's take a look at that. So before I had about 6,000 total entries, and 147 of those were for page splits. This time, half as many log entries, and only 2 page splits were required. So much faster, much less transaction log used, and I didn't grab the number before, but the number before, number of pages that I had to back up with my transaction log backup was around 2,000. This time it was only around 500. So better performance, less fragmentation, and smaller and faster transaction log backups. That is a great reason to pay attention to index fill factor, especially when it comes to talking about transaction log performance. And that brings me to the end of the presentation. I thank you for those of you who have stuck around up to this point. And Scott, what kind of questions have we got? Are you on mute, Scott?
I am. I do apologize. I was trying to click to unmute myself quickly enough, and it didn't work quickly. So
Don't
we
sweat it.
do
I do
have,
that all the time.
yes, we do have several questions that have popped up, and so
Mhm.
I'll kind of go through these. And just to make the offer, if you do have questions, feel free to go ahead and post them in the Q&A section, and we'll try to see what we can answer. The first question kind of goes back to, I think, what the question I interrupted you for earlier. They're looking in one of your slides that you were actually listing one VLF for something else, and was curious, is this something that was based on the original file size in one of the slides concerning the numbers? And I don't remember
Let me
specifically what
see.
slide that was.
Let me see if I can get back to that slide here real quick, and we'll go from there. Pretty sure I know exactly what we're talking about.
Exactly.
I'm guessing it was this slide right here.
I believe that's correct.
Okay. And what was the clarification they were looking for?
That's exactly what they were looking for.
Okay.
Was the slide itself.
Okay.
So that's kind of, I think, where they were going, trying to get those numbers tied down. So
Exactly. And the
um,
whole reason for that obviously was, having the single VLF. It makes that recoverability that much better.
Exactly. So thank you. I think that's where they were going with that
Sure.
initial question. So the next question is a little bit more direct. Roman asked, should I do a checkpoint with the simple recovery model before shrinking a log file to reduce disk space? It says that this is a problem with their data warehouse often.
Okay. Well, if you're, my first thing would be is if this is something that you're having to do on a regular basis, I would try and avoid that if you can. If you're anytime you have to shrink a log file on a regular basis, it's telling you that basically your log file is too small. So I would try to get more space for that log file as much as possible. Now, in regards to the checkpoint, again, really all of that checkpoint is doing is it's taking those pages that were modified in the buffer pool memory and flushing those to disk. SQL Server is not going to hold on to the transaction information that's in that log file. So when you go to shrink it, and I believe, if I recall correctly, when you do a shrink on a log file, it may actually call a checkpoint in and of itself. It's not hurting anything for you to do it, but I don't believe it's necessary for you to do a checkpoint before you do a shrink on a log file.
Okay, and these next couple questions are similar in nature, so I'll go ahead and read both of them to you. You can figure out, I think you can address both of them at the same time.
Sure.
One of them's asking how to find the size taken in the log by a particular transaction so you know if to kill it. And then the second question is, and I sort of know the answer to this, but I'll let you go and answer this particular one. If you kill a long-running transaction, like for instance one that's running for several hours, is there any way to make it faster in order to kill that particular transaction?
Okay, so I'm going to take the second one first. Is there any way to make that go faster? No.
Yep.
Sorry. I wish there was. I would love it if there was. I don't have enough fingers and toes to count the number of times where I wished I could have made that faster, but you're really bound by SQL Server's ability to just process I/O at that point. It's got to read through that transaction log, write all those compensation records in. It's going to take about as long as it can take. Now, some transactions, even if they run for a very long time, depending on what they've done, it depends on the number of modifications that they've made. They may actually have quicker rollbacks. It's not a certainty that if you have a transaction that's been running for 3 hours, it's going to take 3 hours to roll back, but the potential is there that it could take up to 3 hours to roll back, and that's what you have to kind of watch out for. And my apologies, my brain is not firing all cylinders today. Can you repeat the first question again, please?
Sure. They were wanting to know if there's a way to find the size of the transaction to know if they do kill it, approximately what it's rolling back.
Yeah, absolutely. In that demo that I did a little bit later in the presentation, which was after these troubleshooting sections. Yes, the identifying large transactions demo. The script for that, there's a query in there that you can use that will actually show you how much space has been used in the transaction log for that transaction. It'll also show you the start time of that transaction, and that can give you an idea of how long that transaction might take to roll back.
Okay. Next question relates more to the physical storage side. They're asking, is there particular recommendations for isolating log files if they are using their own storage, such as NetApp or 3PAR?
That's a conversation that you've got to have with your storage administrator, unfortunately. I've been actually very, very lucky in the last couple of positions I've held. I've had really, really good storage administrators.
That does help.
Yeah, absolutely. As far as something like a NetApp or a 3PAR, a lot of it depends on how they've allocated things out. I know with the really, really large aggregates that they use on NetApp, it kind of depends on what performance you're getting out of the NetApp as a whole. That may be a situation where, well, let me back up. This is what I would actually recommend. If you're using SAN storage for your log files, which almost everybody is at this point, your storage vendor is going to have a list of best practices that they're going to have for SQL Server, specifically detailing how to set up for best performance for log files, for data files. So don't be afraid to get the SAN vendor involved, get their documentation and say, hey, this is really how things should be set up for SQL Server, and review that with your storage administrator. They may have some tips and tricks for those particular products or models of SAN that is going to give you better performance. But that's a conversation that you've got to have with your storage administrator and probably with your storage vendor as well.
Exactly.
Get as much performance as you can.
And I know we have time for just a few more questions, so we'll try to do a couple. And there's a couple that I'll wrap together. And folks have asked several times, what was your blog address again? And then if you are going to post, or if these scripts are available on that blog address, and I knew you had posted that on one of your slides, and we can show that real quick. And of course, folks, remember too that this is being recorded, so once the recording is available, you can also grab it from there.
Yep, and there's my blog address right there on the bottom, dmmaxwell.wordpress.com. If you go out to that website, at the top there's a link that you can click on for resources, and that has all the resources that are available for all of my current presentations right now. There are a couple that are in storage because I'm reworking a couple things, but that's where you'll be able to get the scripts. Now, the scripts that you download from there might not necessarily match the ones that you've seen in the presentation, because sometimes I will tailor things specifically for specific presentations. As a matter of fact, if you go to that link and download the presentation slides, they're going to be different than what you're seeing right here. But going to the website, that guarantees you that you're going to get the most up-to-date and complete version of this presentation.
Okay, and I think we have time for maybe two more questions. And this one is relates to virtualization, and it says, does your VLF structure change if virtualization is involved?
Does the VLF structure change? No, the VLF structure definitely does not change, although there may be some storage considerations when you're talking about virtual machines. I know there's a white paper, I can't remember the title of it off the top of my head right now, but I will look that up and I will post a note on it about my blog that talks about the different storage that are available for both VMware and Hyper-V, and which ones are better for SQL Server. I'll have to look that up.
Okay, and then the last question, and then we'll go ahead and wrap up. It asks, is there a particular way of reducing, let's say, what are the steps in reducing the current amount of excessively high VLF counts?
So just to review those steps again, whoops, going the wrong way in my presentation here. So just review those steps very quickly. I'll actually go right to the slide.
There you go.
So there we are. So those steps are going to be, you need to determine the correct growth settings first, know where you're going to set the size of that particular transaction log, and again, that's going to be based on what kind of workload that database has and how many concurrent open transactions you're going to have. And really, the best way to do that is if you can take a trace that allows you to replay that workload, do that and replay that workload on a test copy of your database elsewhere, and then just see how big the log gets.
Sounds good. Sounds good.
And you can go from there, and then shrink it down and set the size.
We'll go ahead and wrap up our presentation. I want to thank you for attending our Turbocharged Transaction Logs webinar today. I certainly want to thank David for his time and his expertise, and I'd also like to, of course, thank our sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsors, SQL Sentry, SolarWinds, and AD. We hope you've enjoyed the session as much as we did. Of course, you can follow us on all the different social media, including Twitter, and using the hashtags that pass, 24 HOP, and SQL will pass. So again, this recording will be posted within the next week or so, and we want you to go, of course, stay tuned for the next session. Go ahead and jump over to the next session, which is introducing the Power BI Designer with Stephen Wake. That's going to be happening probably right now. So thank you again for attending today's session.